So in this case, we are trying to understand what is the cone of friction. As you know, the friction always opposing the motion of the body when it is trying to move in the forward direction because of the interlocking of the surface asperities. When the surface asperities are going to be knocked off, automatically the body will gain the velocity and it is going to be moving in the forward direction. So in this case, I am going to be taking here, so one horizontal surface and one body I have taken over here. So in this case, what will happen? The self-weight always acting in the downward direction. Okay, at the same time, the reaction force is also going to be coming from here. When you are applying the force in this direction, that's going to be, and the frictional forces are going to be coming to here, F. The frictional forces are coming. In this case, what will happen? We have taken the individual components N and F, but we can get the resultant component, the resultant reaction forces also we can take it. That I am going to be taking, making with the vertical is going to be R and I am going to be say. And this is going to be making an angle of pi. So the pi is going to be called the angle of friction, and Rn is we are going to be called the reaction normal force, and then N is going to be normal reaction. This is the frictional force, and this is going to be the applied force in this case. So then what will happen? I need to find out the cone of the friction in this case. Can you see? I am going to be replacing the N and F with their respect to the resultant component of the N. This is going to be called the component forces. So then what will happen? I am going to make to rotate about this axis. I am going to be say, suppose this is the point is going to be say the center point C, and this is the point I am going to be say A, and this is going to be the B, and this is going to be the C, suppose. So then what will happen? I am going to be taking the AB, right, and I am going to be make this AC, I am going to be make to rotate about this part in the 360 direction. So then in this case, what will happen? Because the force is going to be acting in this direction, right, and this one. So now I am going to be taking the 360 degrees. This P is going to be applying on this body in the 360 direction. Suppose this is going to be your body. So then in this case, what I am going to do? But initial conditions, the force is going to be acting this phase 1. Okay, so then I am going to be applying on the phase 2, and this is going to be your phase 3, and this is going to be your phase 4. So can you see, this is going to be the force P is going to be acting over here. So then what will happen? This bottom surface is going to be rested on the horizontal plane. So then this is going to be reaction forces are coming in this way, the body is fine. When this force I am going to be shifted from here, from this position. So this P is going to be acting, the body is trying to move towards this side. So then in the same case what will happen, this reaction force is going to be coming from that side, right? The frictional force is going to be moving towards this side. This is going to be your frictional force is going to be coming. And similarly, when I am going to be applying at the point 3, the body is trying to move, but your frictional force is going to be acting towards this side. But when I am applying, the frictional force is coming opposite to this part. Can you see here? I was applied the P in 360 degrees direction. The applied force is going to be applied in the 360 degrees directions on this body. Then I was find out the frictional forces on this one. So then I am going to be make it, the AB is going to be the make it constant. R's AC is going to be make to rotate about it. So that I am going to be draw over here. So in this case what will happen? I am going to be taking the same body in the two-dimensional objects, and then this is going to be the look. So this is going to be your A, and this is the B. So this is what is this one? This is going to be your normal reaction. At the same time, in this case, what will happen is the FF is going to be the frictional force, but I have taken the resultant component Rn, which is going to be making an angle of phi. So then already I told I was the P applied on the 360 degree directions. Then what will happen? This Rn is going to be shifted to this position. This is going to be your Rn. At the same time, I am going to be joining these parts. So there we can see the cone is going to be formed because of this. The applied force is going to be one side this side, another this side, another this side, and next to that part. So then this is going to be called your cone of the friction. Yeah, I am trying to simplify this one. I am going to be taking here. This is going to be your A, and this is going to be your B, and then this is going to be your Rn, which is going to be making an angle of pi. So this is going to be your ABC. I am going to be say. So then I am going to be make it and make to rotate about the same. So then this is going to be, I am going to be say C dash, and this is also making an angle of pi. Join here. So this is going to be called the cone of the friction. Here is going to be your body is there. Right? I hope you are able to understand here. Okay, so that's going to call the cone of the friction when we apply the force in the 360-degree directions.